Hello, Bobcats. I come to you again at the turning of the tide of a new lesson. Today we're talking about dividing rational expressions. Yesterday we talked about simplifying and multiplying them. Today we're going to conclude this section with dividing. So that should be your learning goal, how to divide rational numbers. All right, so of course it's important to remember that when you divide fractions, you keep, you change, and then you flip the second fraction. Um, More algebraically speaking, though, what we're doing is when we divide fractions, we're multiplying by the reciprocal. All right, so to do this, we want to divide and we want to assume that everything is defined. All right, so we have 4x to the x cubed over 9x squared y, but we're dividing by 16 over 9y to the fifth. So we need to remember that this really times 9y to the fifth over 16. All right, now we would multiply. Well, actually, why don't we go ahead and check and see if there's any simplification that could occur. The 9's are going to cancel out. The 4 is going to become a 1, and the 16 is going to become a 4. X squared and the x to the third up in the numerator, these are going to go away, and this is going to become x to the first. And then y to the first, and y to the fifth, that's going to become y to the fourth. All right, so now that we've done all that simplifying, it looks kind of messy. What we have left is an x and a y to the fourth. So x, let me go back into white. X times y to the fourth over, in the denominator we have a 1 over here times a 4 over 4. X times y to the fourth over 4 is our solution. All right, let's look at problem B of example 1. Again, same rules. We want to assume that everything is defined. All right, this time a little bit more challenging. Of course, we want to remember that, like I said, we're going to keep, change, flip. We're going to multiply by the reciprocal. So let's go ahead and do that. Just write that out first. X to the fifth take away 4x cubed over x squared take away x take away 2 times x squared minus 1, kind of red flag there, FYI, and then x to the fifth take away x to the fourth take away 2x cubed. All right, so now that we've rewritten that, let's look for opportunities for factoring. And there are some. Over here, x to the fifth and then x to the third, they're both going to share a common x cubed. So we could factor an x cubed out of them, and then we would get x to x squared minus 4. Down here we've got another trinomial. We could factor that as x minus 2 and then x plus 1 times, and then we have a difference of two squares right here, x plus 1, x minus 1, and then down here we probably notice that they all would have a common, at the very least they would all have a common x cubed, so we can factor out an x cubed from them, leaving us with x squared minus x minus 2. All right, now we might want to take the first step to clean up a little bit of this. There's even more cleaning up that we'll need to do in another step, but let's just take things, just clear up a little bit of the clutter. The x to the first, x plus 1 and the x plus 1 could cancel out, and then the x cubed and the x cubed could cancel out. All right, so now let's take it up here, and we'll do a little bit more simplifying. The x squared minus 4, that's a difference of two squares, so that's x plus 2 times x minus 2. divided by, and now you can see why this is important, there's an x minus 2 right there, times, then we have an x minus 1 up here, and then we have a trinomial down here that we could factor. That would be, again, just like we did it earlier, x, what did we say that was? Minus 2 times x plus 1. All right, now we can factor out a little bit more. Excuse me, we can simplify a little bit more. We're going to have an x minus 2 that'll cancel, and an x minus 2 that'll cancel, and is that it? I believe that is it. So, so at this point, we're left with the quantity of x plus 2 times x minus 1 over x minus 2 times x plus 1. All right, so now we want to FOIL those, and we'll be done with this problem. So this would be x squared, and then I'm going to skip a step here, minus 1x plus 2x's is going to give us plus an x, and then a 2 times a negative 1 would be minus 2. All of that over, that would be an x squared, and then plus an x, and then minus 2x would give us a negative x, and then minus 2. So we are done. That's as simplified as we could get. All right, so why don't you guys try this one and try this one. Okay, one more example here. Example 2, solving simple rational expressions. Well, when we do this, we want to, of course, use the strategies we've learned in the last couple videos. We want to try to simplify if we can before we start going to try to solve it. And of course, there's also a little caution note right here that when we do this, we also want to make note of values that might make this be undefined. And so really quickly, let's go ahead and do that. If we're looking at this, we should realize that, hey, if we had a negative 3 right here, this would make this undefined. So it's important to note that negative 3 would make us undefined. All right, so let's go about trying to solve this. We hopefully notice that this is a difference of 2 squares right here. So this would be x plus 3 times x minus 3, all of that over x plus 3, and we know that that equals 7. We know that x plus 3 over x plus 3 is really just going to be 1, so these will factor down into a 1 or simplify into a 1. So at this point, we're left with x minus 3 equals 7. So we add 3 to both sides, and we get x equals 10. We can then check that, plug it back in. 10 squared is 100, take away 9, that would be 91. 10 plus 3 is 13. 91 divided by 13 is indeed 7. But of course, we want to note that we cannot have this function be negative 3. If it's negative 3, then it's undefined and doesn't work. All right, let's try another one. This time we want to make a note that if x was a positive 1, that would make this undefined. So if when x is 1, we are undefined. So we want to make note of that. All right, so let's go ahead and start factoring this. We need numbers that will multiply to 4, but add up to 3. So that would be a 4 and a 1. We would want we want a negative 4, so we want a positive 3, so we want the 4 to be positive, the 1 to be negative. Then we have an x minus 1 in the denominator, and that equals 5. X minus 1 over x minus 1 is going to simplify into 1s. So at this point we have x plus 4 equals 5, take away 4, take away 4, x is equal to 1. So because x equals 1, and we said that x can't equal 1, this gets undefined if x equals 1, that means that in this situation there's no solution. So the answer here is no solution. All right, try this one and this one, and we'll see you in class today.